Okay, so for two samples, first you need to decide if it's independent or not. If it's independent or if it's dependent. Because if it's dependent, it's basically one sample. We just kick this out from two samples and say, it's one sample. Okay, and then there are three different scenarios for two sample test for population means. Okay, so two independent or two dependent. If it's independent, that means samples from two independent population. That means one of the population has no relationship with the other population. If it's dependent, also called its paired test, is if it is when each measurement in one sample is matched or paired with a particular measurement in the other sample. So if there is internal relationship between the two samples, that's going to be dependent. So typical example, a paired or dependent test, that will be pre or post experiment. Before I take the drug and after I take the drug, and then date of paired tissues from the same animal, right? You're taking like a tissue from this mouse from today, tomorrow. That's gonna be the same thing. This is gonna be from the same mouse, and then from family or sibling data. Yeah. Especially you get twins, you test something on this one, test something on that one, that'll be definitely paired. And then, so here is kind of, let's go through a little bit of example. So, decide on the weight and before and after a diet. So that's gonna be dependent because I am taking my measurement before and after. And then the second one here, 60-second pulse of male and female, because male and female, they're not really, this group of female, this group male, there's no internal relationship, so that's gonna be independent. So based on the basis of salaries before and after, you see this, that's gonna be dependent. Okay, so there are four cases. First, it's gonna be two dependent, and dependent means that's matched or paired. We're gonna kick this one out because it is essentially one sample. Okay, and then here there are two. All of those three are independent ones. So this is independent with population variance unknown and equal, and this is independent with population variance unknown and unequal. This is what we learn in class. What if two independent population with known population variance, both known? That don't really happen. If you know the population variance, you probably know the population mean. You don't need to test anything. That's really, really rare. We're just gonna ignore it. So now there are so comparing stuff, right? So the population dependent, yes. Oh, okay, if it's yes, it's dependent. This one is one sample test essentially. And okay, we're just gonna go this is yellow here, so we're just gonna go through this one. So now let's do this. So we're studying before and after. So now we know it's definitely dependent, right? And we want to know, okay, in patient who have this disease. So this is gonna before and after. So difference is after minus before. We wish to know if this data provides sufficient evidence to allow us to conclude that whatever after this is gonna be the H1. So the surgery increased this. So now we know both of these two are dependent. That's why we can do it D equal to post minus pre. And then, okay, what's the non and alternative hypothesis? So this one, the H0 is going to be this one equal to this minus this one is 0. And this one is going to be, because what we want, okay, what we want is this one increase. So we want this one to be greater than this one. So this one minus this one is greater than 0. So does this surgery increase this factor? Yeah. So now, sample matched or paired and smaller than 30. where n is the number of pairs. So here we do have, yeah, so here because it is essentially one sample, even though there are a lot of, like there are one, two, there are 12, there are 12 observation here and 12 observation here. It's like, there are 24. No, actually it's only 12 because n is a number of pairs. Okay, so degree of freedom equal to n minus 1. That'll be 11 for this case. N is 12. Yeah, and for the t distribution, the x bar, d, and SD are the mean and standard deviation of the difference scores. So here, so the data we're actually using to test is this one. Yeah, it's paired t-test. And now, right, okay, so approach 1, output using original data. We can say t-test pre equal to post, and then you have the result, this mean is pre minus post, and then as you can see, it's paired t-test here. And do you remember our h1 is this one greater than this one? Oh, post is greater than pre, but here you see the definition, pre is minus post. So here we're just gonna say pre minus post because this one is a plot, this is a bigger sign, so now we're choosing the small sign. Okay. And then so decisions will reject it. And t-test instead, default option is the paired t-test. See, I didn't really say anything, so it assumes it's a paired t-test. If you don't know how to read the command, you can always see what's in the title of the table, right? So you don't say anything here, it automatically gave you the paired t-test. Okay, so for the second approach, we're using the mean differences. So now we're just doing the t-test difference equal to 0, and then this is the result. Now, because the way we define difference is post minus pre, and this one is greater than, so here we're choosing greater than. Then we have the conclusion here. Okay, now what before the picture, this one is yellow, no, this one is yellow, that means we're doing the two sample t-test with pooled variance. That means the variance is equal. Yeah. So here, there are, okay, so read this problem. And after reading it, you will realize, okay, there's control and there is SCI. And sample are independent. So we have two samples. And we do not know the population variance, only sample variance. So now we do the hypothesis. What's the null and what's the alternative? So this is null and this is alternative. We want to test if the average is lower for the control. See? Is the healthy, do the healthy subject exhibit lower pressure than SCI? Right. Healthy is lower. Actually, this one should be healthy subjects lower than the SCI. So C is lower than S. C is lower than S. Pressure. Yeah, this should be for the healthy. Yeah, sorry because I'll correct it on the slide. Now, okay, now first we're gonna do is test equal variance. Do they have equal variance or not? So this right. So we're using the SD test. We're gonna say control equal to SCI, and then we're definitely gonna choose this one because equal or not, right? And okay, so because it's 0.2 is greater than 0.05, so we cannot reject it. So we're gonna say the variance is equal. And then with the equal variance, we're gonna test the second step. That's the actual goal of this whole test is we want to test if the mean is equal. So now we're choosing this one. So t-test instead default option is paired t-test. So if you're using unpaired, you need to say it. You might have error or saying this is something wrong. There should be a comma here. Just remember this. Sometimes you don't do this, it gives you error. It's definitely gonna give you error. So if unpaired has been specified, you need to say it's unpaired. Okay, so we fail to reject the null because it's greater than 0.05, this number. So we will say that the population mean is less for healthy than for SCI. Okay, now let's move into the third one. Is we don't know the two groups are independent. Sorry, the two groups are independent, and the variance are not equal. Okay, so here I just tweaked the data from last one, so the variance is different now. So now here this time we're looking for the difference between the two population. Okay, now we're doing the SD test. See, this one is smaller than 0.05 now. And the second step of this test, sorry, it's not second step. The second test of this case is gonna be tested the mean, if their mean is gonna be equal to each other. And then here is 0.1, so we fail to reject. We will say we do not have enough evidence to reject that they're the same. So here are the data command you're going to use. It's quite self-explanatory. So between these two, I will explain in the next slide. So as you see, this is paired t-test. This one is basically one sample. And, because there's nothing about unpaired, so it is paired. And then this one is for the variance. You are testing like this. What we're using today is actually this kind of command, but I will explain what is this one later. And this is the t-test. See, this one is unpaired, and this one also says unpaired. The difference between these two is this one is unequal. So, okay, now if normally what data you have is like this one, so you need to say it's unpaired because it seems like they're in the same row. Maybe they're paired, so if you don't say it, the computer will treat it as paired. This is the kind of data you're using most of the time. So this is what happens when you don't really, it's not two column of two different one. It's gonna be all the numbers here, and then you have the type. So actually this kind of is called long and this is called wide. You can transform these two kind of things, but if you have this kind of data, you want to do this test, you're using this because this is the by command. There is a by command here. You can kind of, by this command, you're separating this two. You're gonna separate this, some, tell the computer to separate this way. So that's why you don't need to say it's unpaired, because there's nothing to pair with it, right? And I know some students, when they Google stuff online, they were using this command, but in the homework, this is the kind of data you have. Okay. Oh, end.